so happy and excited to be here. This is hands down my favorite conference because I am such a nerd for this stuff, which I think my talk will probably also demonstrate for you. So thank you. My name is Joy. I'm the Director of Infrastructure Engineering right now at a company called StrongDM. I have been working in systems and network engineering since 1996, when I dropped out of my art degree and just kept working in the computer lab at my college. So in this talk, I'm going to go through my thought process for building and maintaining a highly available system. It's high level, it's not specific to any given technology. What it is the talk I wish I had when I started out, and it's the talk I sort of end up giving to like junior engineers who are coming into the DevOps space. We have so many tools and services available to us now. We can truly build a service that heals itself with minimal human intervention and without the huge overhead that used to come along with this. Something that I want everyone to take away from this is, don't underestimate the importance of your time. You do not deserve to be woken up or pulled out of your life for spurious alerts. The work of systems engineering is the work of putting things in place to prevent that, not rote tasks that you haven't gotten around to fixing in a systematic way. One way to quantify the value of your time to your employer is to identify how much a person hour costs. I have done this. It was super interesting. If you can ask your people ops team, your manager, tell you how much they pay for an average engineer. It's usually more than your salary. It includes taxes and benefits. And if you figure 40-hour weeks, maybe 48 weeks a year, and math it out, about $150 US in salary works out to about $100 an hour. So there are no shortcuts to resiliency work. And so if you don't spend this time at the beginning, you will have to spend it later. In the meantime, you'll have a lot of interrupts, fires, and they will suck the life out of you and everyone else who has to maintain this brittle system. That will make your team brittle, and you will lose its ability to solve problems and build resilient systems. So let's set the stage with some context. What is the biggest problem that you have when you're starting a business, when you're at a startup? You don't have enough people and time to do the work, and that problem never goes away unless the business is failing, which I also know about, but we're not getting into that here. But if things with your startup are going well, you are going to keep growing. More customers will mean more load on your systems, and as things grow, you'll run into different problems at different levels of scaling. So if you don't start smart, or if you get smart, you will be behind all the time, and you'll be playing catch up, which is incredibly difficult for several reasons. You won't be able to turn around features your users require. You won't be able to fix minor bugs that your users need fixed. You will burn your people out, and high churn will then burn more people out. You won't keep good people, and then you'll be flailing even harder. And teams will spend large amounts of time building around problems instead of solving them. So to avoid this, let's discuss a few pitfalls and how to avoid them. Adding complicated pieces of machinery at the start that you don't have a clear need for. Folks tend to make assumptions about requiring certain technologies when realistically they are adding complexity for little purpose. Kubernetes is great, I'm not slamming it, but do you actually really need it? Or do you just need a simple autoscaler? Start as simple as you can get away with and add complexity as your needs evolve. You can also start with a service that requires minimal configuration effort on your part, like Render or Heroku, to defer complexity, but make sure you understand their reliability story and be prepared to deal with not controlling that underlying service. Another pitfall, not writing up configuration as code right away. I know it's easy to wait on this. I've done it myself, but do yourself a favor and don't. Once you have your service working, code it up and start it up again and again and again. Do it until you can bring up this environment working from scratch. Because, if you can't start this with production, you can get it going with your dev environments, and that will help you get to that place. I use dev environments not just for application development, but also for infrastructure development. Another pitfall, not documenting what you were thinking. You can figure out a lot by looking at code, but you will know even more if you have a written overview and a diagram. You can also document your architectural decisions so that you know who to blame in 2 years when you're wondering why things were done a certain way. Hint, it was you. There's something called architectural decision records that are a good framework for thinking about this problem. I'll have a link to them in my references. Another pitfall, not instrumenting your code. You don't need to go overboard, but give a thought to what you want to see happen in your system. What will help you troubleshoot when something goes wrong? Sitting down and thinking about this as opposed to just making assumptions is a really good way to understand this. Do you need to record latency and errors in your API endpoints? Maybe you should instrument for tracing right off the bat if your system's fairly distributed. Structured logs are good, but sometimes you also just really need good metrics. And let's pivot to some fundamentally good ideas. These are things that'll give you confidence in your decisions and will help you. You should research the systems you want to bring in. Now it sounds obvious, but make sure that no matter how excited you are, you know the downsides of the system as well. I have been guilty of this. Understand how it fails under load, how it handles unexpected data, and how to recover from failure. Think about what it was designed for initially, and then think about how well your use case matches up to it. And make sure you either have existing expertise on your team, or you have to invest in making sure folks can learn any technologies that are new to them. If you pick something good but complex and hard to learn, it's going to be hard to maintain. I know, because at one point Heroku hired all the Erlang programmers that we could, and then we couldn't find any more Erlang programmers. Make sure that everything can self-heal. If it doesn't, you better have a really good reason to bring it in, because you'll be on the hook for fixing it when it does break. Self-healing, let's talk about that. I think we all kind of have an idea, but giving your system the ability to heal itself without additional human intervention. Self-healing assumes that components of any given system will fail for a variety of reasons. Entropy will come for us all, and we need to think about how to automate away that constant fight. If you have a large-scale system, at some given point, everything's going to be in some minor state of failure, just like our bodies. One of the best descriptions of resiliency and self-healing I've heard comes from Dr. Richard Cook's talk on the resilience of bone and resilience engineering. I'm putting a link to that, again, in my references for the slide. Seek it out if you can. It's amazing. So here's some basic services that you can use to bring things back to health. And again, you're probably already using them, but it's good to really think about this. So auto-scaling groups for stateless systems. You can use metrics, absolute numbers to bring your system pool to a healthy state. Sometimes it's even just like an auto-scaling group of one, and you just have like a service that doesn't need to be like very available, but mostly available. State machines. For stateful data, if it requires more care and automation, because you can't lose that data. You can't just shoot it and let it come back. State machines are a lifesaver. They allow you to attempt standard processes and then feed back into that loop. I think we've probably all thought about them a little bit, but I've seen them work really, really well at Heroku to automatically fail over their databases, and they managed to get, at the time I was there, 1 million databases with a 10-person on-call rotation. And when these tools fail, you need to alert an adult to let you know what's going on, but you've already gotten most of the easy stuff out of the way, and then you can actually think about how to solve things in a creative way. Another option is the deadman switch, something like deadmansnitch.com. You need a watcher for your watchers. This is useful for canary monitors, other automatic systems like your state machine to make sure that they're running. Because there's really nothing worse than being like, well, why did my automated system go down? It should save itself. Why didn't it alert my canary? Oh, my canary's down. Come up with several systems designs, at least in early stages. Everything has some positives and negatives, and even if you have an inkling of what the right solution will be, keeping a broad outlook means you can incorporate good ideas you wouldn't have had if you didn't force yourself out of your comfort zone. There are so many times where I, in my hubris, I'm like, no, I know I'm going to build this system. Give it to someone else, and they're like, have you tried this, this, this? What about this? And I'm like, oh, no, okay, thanks. In that same vein, asking for feedback from coworkers and other folks is appropriate. You really need to remember not to get defensive and embrace feedback as a gift. Other people are sharing their knowledge with you, that's awesome. You don't need to use their suggestions in the final product, but you do have a chance to learn something new. So here's some concrete steps I follow when I'm architecting a system. I kind of took this from my last role where I built out an API for a spatialized audio. I usually do this visually by diagramming a system and walking through it as traffic would traverse it. But you always have to start with your user story. You think about who needs to use the system, what do they need to do, who will be responsible for maintaining the system, and what's their knowledge base, and what are the inputs and outputs of the system. This is basically product management, but we don't do it very much in infrastructure, and we should. For instance, here are a bunch of questions you can ask yourself and your team about different components of a system. Okay, now I'm just going to go with a barrage of questions. Do you only need an API? What about a graphical user interface? Can you decouple those things? Can your GUI just talk to the API? What's the entry point to the system? A load balancer? Something else? How does it detect health for nodes and its targets? How do you handle a load balancer outage? Is your load balancer in only one region? Can your API or control plane layer be stateless? How do they pass on their health status to the front end? What happens when one of those machines fails? How will that system heal itself? This is why developers hate me, by the way. Do you need other components to connect to? You probably do, and they probably need to store state because, I mean, come on, it's not real if it doesn't have some state. You might need to stream a lot of data. Is that going into a clustered system? What happens when any given node in the cluster goes down? Are there any special nodes in that cluster? How much data do you have in your system, and how long will that take to replicate or replay? How will that system heal itself? What about a database? Again, is it a cluster? Where do the writes come into the database? What happens when that fails? Do you have a replica locally? Do you have a replica around the world? Where are your backups? How long would it take to restore them? Have you tested them? Where do reads happen? Do you need to read and write from the same or different systems? If the main writer fails, how does it get replaced? How can it self-heal? Again, I'm going to keep going. What about caching? How often does it refresh its state? What happens when any node in the caching cluster goes down? Can your system handle load without the cache? Or would it be overwhelmed to start from a cold cache? Can you scale for this? If you moved your application somewhere else, would you need to persist the cache, or could you just start over? So, you gotta take yourself through all these questions for every component you add to your systems and be methodical. Maybe you're using a service with Google or AWS that will handle this on the back end for you, which is awesome, especially if you're a small company just starting out. But in that case, you're not off the hook. You need to research how those systems handle failures and how they report them back to you, and thus your other systems. I have certainly been guilty of assuming that Amazon does something the way that, in my mind, is the only logical way to do things. They do not always do that. And then interconnects. Obviously, the system isn't going to work, especially if you got microservices or something like Kubernetes, or if you don't have network. What happens when a client loses its connection to an API host, or the API host loses its connection to a streaming server? How do these services report an error? What happens on a timeout, or when a server accepts a connection and then just doesn't do anything with it? Maybe because it's crashed, and metaphorically it's sitting glassy-eyed on the couch, like I do sometimes. Take yourself through these interconnect cases the same way you did for the self-healing cases. And then, with all of that in mind, now is the time to talk about observability. How do you observe in your system and alert if things go wrong? As we all know, it's the unknown unknowns that'll get you. Thinking through everything will put you in a good starting place, but you will have problems you didn't anticipate. Remember that your system is both individual components and the sum of its parts all working together. You'll want some way to know that the users of your system are seeing what they should see. This is where the concept of a canary or synthetic tests come in. The goal is to set up something simple, ideally coming from outside the system, that follows the path the customer would likely follow. This can be quite simple, and probably should be. A lot of people use functions as a service or a third-party platform to do this. The things that you want to measure, we all know, my holy trinity, availability, does it respond, latency, and how long, and errors, is it correct? Think of it as a sentinel that should alert loudly if something goes wrong. And if you have no other alerts, this is a good place to start. For a long time, I had one alert. It was a canary, because I was like, well, the rest of the system's pretty simple, but what I really need to know is it working? If your canary isn't reliable, your system isn't reliable. You have to have one alert you can truly depend on. It's way more valuable than several you're not sure of. As a bonus, this is usually what you end up figuring your SLA off of, assuming you have customers with SLAs in their contracts. So that's the warning light, or as my stepdad who worked for GM liked to call it, the idiot light. But what about individual components? And this is where you're thinking more granularly for metrics and alerts. This is where folks run into problems with noisy alerts, the kinds that keep you distracted, frazzled, burn you out. My rule of thumb is actually that I would rather have no alert than an untrustworthy one, because I have seen an untrustworthy alert get ignored, and then outages happen, and everyone's like, well, why didn't you pay attention to that alert? And it's like, well, how would you expect me to? 5 times out of 6 is a bullshit alert. If you currently have those alerts and you can't get organizational approval to fix them, this is where that formula for the engineer's time comes in. Figure out, how much time do I spend? How much time do my colleagues spend? And how many of my colleagues spent how much time fixing this? You can, put it in a spreadsheet, show it to your manager. Suddenly it starts looking a lot more sensible to take some time for those. But you do need to see how your system's components are faring. Before you put alerts on it, make sure you have good metrics that actually show you how each system is performing at baseline. Don't throw every metric a system emits at a dashboard and gaze upon it. It is too much for a mere mortal to bear. You'll want to take what you learned walking through the system, remember how we were thinking about all the components, and consider what is important based on what I know about the system and how it acts. For databases, you want to look at things like connections. You want to look at locking and query performance and storage. Obviously, this isn't exhaustive, but think about it. Queuing systems like RabbitMQ or Kafka or SQS. How are things moving through the queue? Is it backing up? Is there a regular pattern? For APIs, what are your most used endpoints? What's slow, and are there any errors? For caching, big one, what's your cache hit rate? Is it providing you benefit? And for system level metrics, like CPU or memory or disk usage or I/O or inodes, you don't need all of those front and center. You should consider what's most likely to be a bottleneck on a given host based on what the service is doing. Does a certain service use a lot of CPU? Like, a spatialized audio mixer? Is it using I/O? Is it, writing data to disk? Could it write and fill up a disk? You gotta bring those front and center. Keep the other system level metrics tucked away until you need them. And of course, metrics are one part of the story, but they're just little plots of data on a graph. Another thing is logging, which of course is a tale as old as time. There are so many options for centralizing and analyzing logs. But what I'm here to say is you just need to consider what you plan to use your logs for and build out that system based on your use. First, make sure you have structured logs, some sort of structure. If you're going to parse out useful information from your logs, you need to have an automated way to analyze them. Because, while I've spent a lot of time in my life watching logs scroll down, journal control-EF is probably one of my most soothing ways of getting through the day. I don't think that, that's a really sustainable solution. If you need an audit trail, like something that, you can basically show to a compliance or a security person, you need to send that to a tamper-proof place. Ideally, has good encryption, authentication. That should not be the logs that you probably need to look at when you're troubleshooting a problem. That's something separate. Troubleshooting, you probably have a different set of needs. If you have like a high log volume and you want to find a needle in the haystack, I'm going to shout out honeycomb.io for sampling logging data, allowing you access to slice and dice it and look for unusual patterns of behavior. But there's other options too. You can use an elk stack if you want to go open source, or CloudWatch logging if you like to live within AWS and are uniquely headache-proof, or something like Sumo Logic if you want to pay a third party to not worry about it. But no matter what you do, make sure your logs make sense. Agree on logging levels and use them. Consider it a major bug when you're overlogging, because overlogging can take down your entire system. I wish it wasn't the case in this year of 2022, but it is the case. If you fill your disk, your service is dead in the water. Still, if you can't log to an overloaded central logging system, that can cause back pressure, take down the service. And even if you haven't, if there's anything else going on, you have a rain of useless messages that you have to wade through. So this is worth putting an effort to fix and consistent housekeeping effort to clean up, because they can save you when nothing else can. Okay, tracing. Okay, yeah, sorry, I had COVID 2 months ago, and I'm still coughing. Isn't that awesome? It's such a great virus. I love it. So tracing can be great. If you've ever struggled to put the pieces of a request together as it travels through a complex system, I'm sure you can appreciate tracing. I don't need to be a tracing cheerleader here. Everyone's a tracing cheerleader here. But it's really logs with a lot of extra useful context. It's like following the entire track of your system. That requires code instrumentation. That will require collaboration between your application developers and infrastructure engineers. Good reason to keep those lines of communication open. And also to note, it can be resource intensive to run and store traces. So you might want to ensure you can turn it on or off with a feature flag. And you want to think carefully about how much data you collect and where you will store it, just like your logs. Remember, don't let your observability turn into a point of failure. For a really good story about this, you can check out Amy Tobey's super awesome blog post, Open Telemetry and the Ghost of Provisioning Past. I will also link it in my references. So visualization and automation. So now we're talking about all of these. How do we incorporate them? Sometimes you want a human to look at your graphs, your logs, your traces. Sometimes you want a machine to analyze them for you. And how should you decide? First, you're not going to be one side or the other. Both are very useful. As a human, we can use our own intelligence to pick up on oddities that a machine might miss. We can get an understanding of what usual behavior looks like, and you can see what's maybe gradually changing over time. Having a habit of looking at it, reviewing it with your team, it's extremely helpful. It feels a little lo-fi and old-fashioned sometimes, but it's also useful. But as humans, obviously we can't look and process everything. We're not good at doing simple things on a regular cadence. That is what machines are good at. And if there's something you need to be alerted on whenever it happens, in the rare cases that you do actually need to do that, it needs to be automatic. The most important thing to consider, though, when you're setting an alert, when you're looking at a system, when you're building this out, is thinking about your customer's experience. They are the reason you have a service at all. I'm not going to get into SLOs or SLAs exactly. Obviously, other people are doing it and doing it really, really well. That's beyond the scope of my talk. But you need to remember that if your customer is having a bad experience using your service, they will probably leave and you will not have a service for long. So let's talk about another aspect of self-healing. Again, something that I'm sure we all have access with or experience with, service discovery. If you have a self-healing system, nodes that'll die and need to be replaced, you need to be able to get them back into service without manually adding them back to a static config. Surprisingly hard, even though it's been a long time. Service discovery, there's a lot of depth in this topic. And I'm just going to talk about a few high-level things and maybe give you some more ideas for, again, what to consider when you're using different components. So, DNS, I love it. It's a lot easier, I think, sometimes these days to mess with DNS than it used to be. I remember bind and always forgetting to change my serial number and then having to go back in. But right now, I gotta say, it's still there. Tried and true method of service discovery, DNS. Obviously, you're taking a name and you're pointing it to an IP, or another name which is also pointing to an IP, or a group of IPs, or something. And round robin DNS is totally a thing, and a very reasonable way sometimes of doing service discovery. But there's things that you have to consider with this. One thing, when a host dies, probably ungracefully, you need to make sure that you're taking its IP out of your DNS record. How's that going to happen? Well, make sure you got something. You can set up health checks in Route 53 at least to see if something is responding before it returns it as part of a record. Again, you need to make sure that that is working properly. You don't want to get your record really bulky, because then even now, if it goes too big, you're probably going to actually see some systems problems. DNS can take a while to update. Remember, DNS is a system that basically only works because all of these sorted systems across the internet agree to do the same thing, and they don't always do it right. You'll need to make sure your service can handle cycling through bad IPs before it gets to a good one, cleaning up that record, and also, you could consider assigning a static IP to your service, like an elastic IP, like if it's small, swapping out the IP when the node fails. That fixes DNS update time, but you still have to think about, okay, how is this reliably going to assign itself to its new IP? So load balancer, DNS, obviously, load balancer, second old school. Things to consider, hosted load balancer, like ALB or NLB, something like that will scale automatically, but won't scale automatically extremely quickly. Or if you're running something yourself, like Nginx or HA proxy or a piece of hardware in the data center, you still really have to think about scale and what your peak is going to be. And if it's auto-scaling, how long it's going to take to scale that. You need to think about what happens if your nodes start dying. Like say those stateless nodes need to just suddenly start getting replaced. Like what is that going to do to the load balancer? How are you paying attention to that? If you do load testing and chaos testing, I think that's one of the most valuable things that you can see is how this works. And of course, if you have a load balancer failure, you're probably having a really bad day. And then let's talk about service registries. Again, whole additional service that your service depends on. And suddenly that service is probably the most important service, because if you depend on something and then nothing, and then that service is having some unknown problem, your other services can't heal themselves or can't even start. I'm not going to get into detail, but yeah, remember, services that you need to use your services are the most important part of your stack. So that's about it. It's wrapping it up. Thank you for listening. I hope that this gave you some good ideas for the next time that you find yourself having to build out a new system, a new component of your system, or even just thinking about like how you want operations to look like in your company. Don't sacrifice your life and mental well-being to a bunch of ungrateful bits of silicon. That's the most important thing.
Time for maybe one or two questions. If there's any questions from folks in the audience? Anything? Make sure I don't miss anything. Give a holler if I miss them. No? All right, great. Thank you so much, Joy.
Thank you.